To just do math? Okay. Guys, I hope that over the break that you were, I didn't spell do it. I hope over the break that you guys did math. Yeah. I don't know. Okay, anyway, so today we have the AP exam on Thursday. Now, I wanted you to do that practice AP exam over the break. We are going to be going over it. Probably won't get too much of it today. We probably will, by the time I go over some things I think I need to focus on, we'll get to a little bit, but not too much. So the homework that I have here in this weird free response question packet, I call this the weird, just like random questions that don't really fit into the 6 types that I've given you. And then that happens. Usually it's like the question 6 they do that with. So I just want you to try a couple of those, but really I won't be able to go over this until Wednesday. So technically, even though I'm saying there's homework tonight, you could do it either tonight or tomorrow. I won't check it until Wednesday, and we'll go over those Wednesday. So, all right. So I'm just going to come around. Some people have talked to me about what they did over the break, but I just want to see that that practice number 1. Okay. So yeah, there's extra help tonight if anyone wants at 5:30 to 7:30. Tomorrow 2 to 4. I was just thinking about things that I think might be a little weak spots that I just wanted to address. Um, One of them being if you have a piecewise function, if you want to show that the limit of the function exists as x approaches a, you have to show that the limit of f of x as x approaches a from the left equals the limit of f of x as x approaches a from the right. And I was just wondering if you would know how to find those limits. How do you find the left-hand limit? Yes, Gina. Yeah. So you would find the limit of f of x as x approaches a from the left. Let me just write it up here. So the limit of f of x as x approaches a from the left, you would just plug it into the right branch, right? You would plug a in. So what would you get for that limit? G of a, right? And then you'd have to find the limit of f of x as x approaches a from the right. And how would you find the limit of f of x as x approaches a from the right? Plug it in, so you get h of a. And as long as those two values are the same, the limit exists, right? So you would, if as long as you get the same value, okay, they're both 7 or whatever, then you can say that the limit exists. So if the, I'm just going to write here. So if they're equal, I'll just, if g of a equals h of a, then the limit exists as x approaches a. It exists and it equals either one of them. They're both the same. H of a, which is equal to h of a. So the first thing usually you have to check with a piecewise function is, does the limit exist? You got to make sure that the left and the right hand limits are the same. If they are the same, and now you want to see if it's continuous there, because remember, a function, the limit could exist, and yet it's not continuous. Maybe the point is just not there, or maybe it's somewhere else. So to be continuous, remember, not only does the limit have to exist, but the function at a has to exist, f of a has to exist, and they got to be the same. So, so now you know the limit exists. It's g of a or h of a, whichever one. Let's say that they're equal. You would have to see if f of a exists. Does f of a exist given this definition? Yeah, what is f of a? F of a is equal to k according to the definition. And let's say we get some number like 7, and let's say that was the value of our limit. Then we could say that the function is continuous at a. So as long as the limit of f of x as x approaches a is equal to f of a, which is k, then we can say it's continuous. So let's say that that all worked out. So the limit has to exist in order to have a possibility that it's continuous, and the limit has to equal the functional value to be continuous. Once it's continuous, then you can check to see if it's differentiable, because there's a chance it could be continuous but not be differentiable, right? If there's a corner, cusp, or vertical tangent. So let's say now we know that the function is continuous and we want to check if it's differentiable. To do that, you have to find the limit of f prime of x as x approaches a from the left and make sure it equals the limit of f prime of x as x approaches a from the right. You're making sure that the slope's approaching the same value for both sides. There's no corner or cusp. So to do that, what you need to do is you need to write up a little piecewise function. So if you got to the point where it's continuous, okay, now maybe it is differentiable here. We'll check. What would the derivative be equal to if x is less than a? We'll find out if the derivative at a exists. So we don't have to consider at a. How about when x is greater than a? H prime of x. So you come up with your little piecewise function. Now you can see what is the limit of f prime of x as x approaches a from the left. What would you do to get that? Or what does that equal? G. But you would plug the a in, so g prime of a. And then you would get the limit of f prime of x. So you're finding out what's going on with the slope as x approaches a from the right. And what would that be? H prime of a. And as long as those two values are the same, then it's differentiable at x equals a. So as long as g prime of a equals h prime of a, as long as those two values are the same, then we can say our function is differentiable at a. Differentiable at x equals a. And f prime of a equals g prime of a or h prime of a. When you say a function's differentiable, it just means the derivative exists. So f prime of a would equal either one of them. They're equal. G prime of a or h prime of a. So whenever you get these questions, in fact, I have one for you to try. Oops, not that one. Like, we have a piecewise function. F of x is x squared when x is less than or equal to 2, or 8 minus 2x for x greater than 2. Bless you. And they're asking you to decide at that breaking value of x, where it changes definition to 2. You know, if it's differentiable, continuous, all that. What do you think the first thing you got to check? If the limit exists, right? You got to find the limit as x approaches 2 from the left and compare that to the limit of the function as x approaches 2 from the right. See if they're equal. If they're not, we're done. Right? The limit has to exist. So what is the limit of f of x as x approaches 2 from the left? What is it? You got to plug 2 in. 4, right? Because it's 2 squared plug it to the first branch, which equals 4. What's the limit of f of x as x approaches 2 from the right? 4. Because you plug 2 into the other branch, and you get 4. So, we know the limit does exist. We know that the limit of f of x as x approaches 2 exists, and it equals 4. And what's the extra little step I have to check to make sure it's continuous at x equals 2? Yeah, we got to see if f of 2 exists. Does f of 2 exist? Yeah, what does it equal? 4, which is equal to the limit. Put a little arrow up here. And that's always going to happen if two is, or whatever the number is a part of a branch. It's like when it's separate that usually you have to, when they have a separate branch just for when x equals 2, usually that's when it gets fun. So we know that this function is continuous because not only does the limit exist, the function of 2 exists and they're equal. So we could just guess now, but we'd be down to 2 choices. So what would you do next? Yes. Yep. Take the derivative of the piecewise function. What's the derivative of the first branch? 2x. We know that that's true when x is less than 2. Let's see what happens at 2. How about the derivative of the second branch? Negative 2. And x is greater than 2. So we know what the slope is as you come in from the left, and we know how to get the slope when you come in from the right. As you get closer and closer to 2 from either side, are we getting the same slope? Because again, you got to do the exact same thing. You got to take the limit just with the derivative as x approaches 2 from the left, and the limit of f prime of x as x approaches 2 from the right. What do you get for the limit as x approaches 2 from the left? 4, right? When you plug 2 into the top branch, 2 times 2 is 4. So the slope as you get closer and closer to 2 from the left is positive 4. And what about from the other side? Just always negative 2. So from one side, you come into 2, the slope is 4. The other side, the slope is negative 2. Not the same. So it's not differentiable. So not differentiable at x equals 2. So f prime of 2 does not exist. That's another way of saying it. Okay, so what's our choice here? Yes. And I hope no one would ever put a choice C. Did what? Assumed it was continuous? But this one you could get rid of. Is that what you're saying? Like immediately? Yeah, this is impossible. That'll never be an answer. Alright, try this other one here. See whether it's continuous, differentiable, whatever. F1. Sorry, kids, I paused it. Okay, look really fast. Okay, you guys check out 1, 2, 3. Make sure the limit exists. It equals the functional value, and the derivative is the same. You can look at that in slow motion. Okay. So for the intermediate value, we're talking about there's a couple theorems that pop up on the AP exam. Sometimes the free response questions with tables. And you want to just be aware what they say. So for the intermediate value theorem, it guarantees as long as the function is continuous over a closed interval, it takes on all y values between the y coordinates of the endpoints. And a big hint that you can use intermediate value theorem is when they want you to show that the function has to equal a particular value over some interval. So this is, I don't know how you guys would attempt to look at something like this. It says, explain why there must be a value t between 1 and 4 such that h of t has to equal negative 1. Yeah. Would you need all of them 1 through 4? Which h values do you really need? Yeah. You need what h of 1 is and h of 4. So that's what you should do first. Because when they give you an interval, because we're hoping this is going to be the intermediate value here. So let's get h of 4. Now, according to that definition, it equals f of g of 4 minus 4. Alright, so we got to get g of 4. So g of 4 is 2. What's f of 2? 8. So the h of 4 is 8 minus 4, which is 4. Now we got to get h of 1, because that's the interval they gave us. So h of 1 equals f of g of 1 minus 1. That's g of 1. 3, and then f of 3, negative 3. And then we subtract when we get negative 4, because it's negative 3 minus 1 equals negative 4. So we know h of 1 is negative 4, and h of 4, what does that say? Is that an equal sign? Oh, it's positive 4. Okay. Does h of t ever have to equal negative 1 for some value of t? You see that? Right? Yeah. And all you would have to say, once you show those values, you know, if you want to draw a little picture, you can to see it, but you don't even have to. This is negative 4 and h. But I'm just doing so you can see. Because we know this function is continuous, you just say by the IVT, intermediate value theorem, h of t must equal negative 1 for some value t between 1 and 4. So, okay, I hope that you can get the visual on this. You can't go from negative 4 up to 4 without at least crossing negative 1 once. It has to equal negative 1 at least once. So, yes, we can guarantee this by the intermediate value theorem. So yeah, when you see, like, you know, they give you an interval and say, oh, you know, the function has to equal a particular value, that's usually what you're going to go for. The other theorem is the mean value theorem. Now, the mean value theorem guarantees that if your function is both continuous over a closed interval and differentiable, this is for all numbers, okay, but it's got to be both continuous and differentiable or it doesn't work. If it's got a corner, it doesn't work. But as long as it's nice and smooth, this is my Walmart truck story. It guarantees that whatever the average rate of change is, whatever the slope of the secant line is, there's got to be a point between these two, some x value between these where the slope of the tangent is equal to the slope of the secant. In other words, the slope of the secant, slope formula, okay, you always get that, has to equal the derivative at least once for some value in between a and b. Right, so the slope might start out less and then be more, but somewhere in between the slope has to equal the average rate of change. Instantaneous rate of change equals average rate of change. So in a question like this, it says, explain why there must be a value of t between 1 and 4 such that h prime of t equals 3. Such that h prime of t equals 3. And they gave us a table for h. How are we going to start this one? Well, the interval is 1 to 4. Think about what the mean value theorem guarantees us. It guarantees us there's some value of t between 1 and 4. We can call it whatever you want. I'll call it c. But c is a number between 1 and 4. Where the derivative has to equal what? What would be in this case? What does the derivative have to equal? The slope, what should I write up here? H of 4. Very nice. So the way we'd have to start this is we'd have to figure out this average rate of change. We're going to have to get h of 4, and I think that's the same as the last table, but they switched it up because h of 1 is not the same as the one we just got before. But mean value theorem guarantees us there's at least one value c between 1 and 4 where the slope of the tangent will equal the slope of the secant. So let's get the slope of the secant. So we're going to have to get h of 4. Now this one is defined the same way. Okay. So I need to get h of 4. That's f of 2. I think this comes out to be 4. It's f of g of 4 minus 4. This one's the same. G of 4 because it's f of 2, which is 8 minus 4. Okay, that's 4. But I know h of 1 turns out to be different. We gotta find that. So it's f of g of 1 minus 1. 3. F of 3 is negative 4 minus 1. Are you guys getting negative 5? Okay. So we know there's some value c between 1 and 4 where the derivative equals h of 4, which is 4 minus negative 5 over 3, which is 3. It's always going to be, if you did the math right, the number that they say. Explain why there's got to be a value t between where the derivative equals, and then it seems like they just come up with this random number. That's the number you're going to get when you do the mean value theory. So we can just say there must be a value between 1 and 4 where the derivative, so I would just say h prime of t equals 3 by the mean value theorem. I mean, for t between 1 and 4. That's all you have to say. That's what we know. Guaranteed mean value theorem. So intermediate value theorem guarantees the y coordinates go through every y coordinate between the y's of the endpoint. Mean value theorem guarantees the slope of the tangent, the derivative, has to equal the average rate of change, the slope of the secant. Okay? I know I'm going to get you with random stuff, but I didn't know how much I was going to see you in the next couple of days. I wanted to get all this in. The last little thing I had to say today, critical values. I want to make sure you remember because this goes way back. You know, critical values, you can only have a max or a min in a critical value. And a critical value is where the derivative is either 0. So yeah, you can have a max or a min where the slope is 0, or where the derivative is undefined. You can still have a max or a min when the derivative is undefined. But those are the only places you can have a relative max or min at a critical value. So if you get the derivative, to find your critical values, you find out where it's 0, and if it's a fraction, that's when the numerator is 0. And where it's undefined, that's when the denominator is 0. So if you get a derivative and it turns out to be a fraction, to get your critical values, find out where either the numerator or the denominator is 0, and then you can make your sign chart. So here's my last little example for you. Here's the derivative. Can you guys tell me what the critical values are? What was it? Okay, because that's where f prime of x does not exist. That's at x equals negative 2, so that's 1. Yeah, and where it equals 0, it's x equals 0, x equals 1. So if we're going to have a max or min, it can't have a relative max or min. It can only happen at a critical value. So when I make my little sign chart up, I don't have to mark it off at every number, right? Just at negative 2, 0, 1. Now, yeah, we check out values, but we have to be smart. We don't want to just make a mistake. Where can we expect there will be no sign change? Here's the bounds, 0. So, you know, if we get a sign change there, you want to check your numbers. Now, x squared is always going to be positive in between these values, so we don't have to worry about that. So if you take a number greater than 1, is the derivative going to be positive or negative? Positive. Take a number like a half between 0 and 1. Negative, because it'd be a negative over positive. Like negative 1 between 0 and negative 2. Negative. And then a number like negative 3. Okay. So at our critical values, at negative 2, what do we have? Max. How about at 0? Nothing either, right? And at 1, it's going from negative to positive, right? So when you do get to trying these strange little free response questions. This is what they tend to deal with. You know, like differentiability, piecewise functions, differentiability, those theorems come into play, and critical values. So I just thought it'd be, yeah, I'm going to stop. I was going to go over some practice, but I went too slowly. Sorry.